We are going to have a look at the linear function. The word linear comes from the word line, or affectionately known as straight line graph by most of the people, or the straight line graph or linear function, or the linear graph. Linear graph, or straight line graph. Straight line graph. Now, what I have here is the y-axis and the x-axis. And this is called Cartesian plane. The Cartesian plane was named in honor of Descartes. Descartes was a philosopher and a mathematician. So we can have that as 1, 2, 3, 4. This will be -1, -2, -3, -4. We'll have 1 here, 2, -1, -2, -3, and -4. Now, we talk of a coordinate which have x and y value. If I go here, sorry, if I go here, I'll have x is 2 here, y is 1. Here, x will be -2, y will be -1. And somewhere here, I'll have 4, x is 4, y is -2. You will appreciate that I can go down that way and have my x there. I can come this way and have my y there. Now, if I join these points, let's say we have another point here at -3 and 2. And let's name these points. This point here, you call it A. We name that one B. We name that one C. We name that one D. Now, if I join AD, I will have a line. If I join AB, that will be a line. If I join BC, that will be a line. If I join DC, that will also be a line. Let's join these points, just as you have said. We join AB. We join AD. We join we are going to join DC. We are going to join DC. We are going to join DC. And lastly, we are going to join BC. If you like, you can join BD, you can join AC, whatever combination you like. Now let's see what's going to happen. Now, if you look at AB and BC, you see the slope here, the steepness of AB as compared to BC are not the same. If you have to run from C to B, and somebody has run from C to D, most people will choose running from C to D because CD is not as steep as BC. That is called the slope. Now, the slope, the equation of a line is given by y, which is equal to mx plus c. This part here is called the slope. Or we call it the gradient. And this one here, it is the y-intercept. That is where the graph casts the y-axis. Now, of interest is m, which is the slope. The slope is given by change in y divided by change in x. Some people call it the rise divided by the run. Rise divided by run. We'll look at this later. Now, a change in science or in mathematics, we must have more than one value. So basically, we can call this x1, call that y1, call this x2, call that y2. So as a coordinate, we will have change in y will be y2 minus y1. Change in x will be x2 minus x1. According to what we have there, y2 is -2 minus y1 is 1. And then x2 is a 4 minus a 2. That will be -3 divided by 2. Now, that is the slope. Now, let's look at the slope of BD and compare the slope of BD as to the slope of BC. We write the slope of BC. We write the slope of BC like this. The slope of BC. So we are going to have a look at the slope of DB. Slope of DB, we have 2 and 1 minus 2 minus 1. We have the B we have the point B we have the point B. We have the point B as 2 and 1. The point D as -2 -1. So if you're looking for the slope of BD will equal to y2 into x2 minus x1. We can choose that as 1 minus 1 into 2 minus 2. The answer is going to be 1 plus 1. Negative multiplied by negative is positive. So 2 plus 2, that is 2 over 4, which is equal to a half. So we have the two slopes. One slope is positive, the other slope is negative. The other slope is negative. We say a negative slope depicts a decreasing function. A negative slope comes from a decreasing function. So BC is decreasing. So decreasing. Is decreasing because the value of the slope is less than 0, which means the value of the slope is negative, while the slope of BD is positive. We say this function is increasing. If a function is increasing, that is to say the value of m is positive. Sorry, the value of m is positive. So don't forget that if a function is increasing, if you move from your left hand to your right hand, and you go up, then that function is increasing. But if you move from your left hand and you go down to your right hand, that function is decreasing. So an increasing function fm, which is positive, a decreasing function sm, which is negative. Now let's go back to this picture here. The diagram shows that AB cuts the y-axis here, and then DC cuts the y-axis there, and AD, if AD is produced down there, is going to cut the y-axis somewhere down there, and if BC is produced up, is going to cut the y-axis somewhere up there. Now, let's get the position where BC will cut the y-axis. This is the slope of BC. Now you go back here. We say the linear function is given by mx plus c, where I explained that this one stands for the slope, then this one, the y-intercept. So now we know that m is equal to negative 3/2. And then you have our x. But we don't know what c is. Fortunately, we have that. But BC have these 2 points. And then we agree that the first is x, the second one will be y as a coordinate. We can use this point or this point to look for C. We are going to use the other one of the coordinates of B, which is 2 and 1. The coordinates of B, x is 2, y is 1. So y is 1. And then our slope was -2. And then our x is a 2 plus our c. Therefore, 1 will equal to 2 will cancel the 2 there, minus a 3. Therefore, c will equal to 1 plus 3. What is a 4? So the BC, the line BC will pass, if 3 is here, will pass that 4 up there. Now, you will realize that this equation here can be given as y is equal to -3/2x plus 4. So you manage to give the equation of a line in the standard form. This is called the standard form.